Okay, so the problem says we have 14 men, 9 women, 23 chairs, and then the restriction, I guess, is that no two women can sit next to each other, right? So what you said was kind of true, where like if everyone were to sit, there would only be one way to make everyone sit. But I think Saad's asking that like in how many ways can people sit? Like you could have all 14 men at once and then all 9 women at the end. But obviously this is not what he wants, right? He wants them to sit in a way where no two women can sit next to each other, right? So there's two ways of doing this, I found out. So let's remember the bits thing we did in class where it's like 0, 1, 0, 0, 0, 0, 1 or whatever. It's kind of like that. But um whoa, I was wrong. Oh, wait. Okay. So let this space be a man can be here. This is a woman, man. Uh that's a blank. And then we just keep doing this. And there's 9 women, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 9 women there, and then the blanks represent places where the men can sit, right? Can sit, right? So for this first box and this here, you don't necessarily need to have a man sitting here. It's just that a man can sit here. You don't need one sitting here because there's no women here, right? So you don't really need anyone sitting here. You could end this off with a woman, right? He didn't have any restriction for that. But between two women, you must have at least one man. So if we call this first blank, it's gonna be very tricky. Let's call this first blank M1, and then second blank M2, third one M3, next one M4, M5, M6, M7, M8, M9, M M10. So these M10 all the way to M1, these are for these underlines, right? That's where the men can sit. So there's 10 possibilities of where the man can sit. And now, similar to the bits problem, I just copied that from there. You make it into an expression. So M1, M2, all of these, just see if this works. All of this added up, and then the question said how many men can there be? Yeah, so there can be 14 men, right? So you add all of them up, so that's equal to 14. Now, remember when I said that for spaces at the end, like this and this, like M1 and M10, you don't really need a man sitting there because this seating can end with two women at the end. So M1 will just stay like that. But for M2, you must have a man here. So M2 is this space here. I don't know if you can see the highlight, but you must have a man here, right? So M2 is greater than or equal to 1. It has to have 1, but it can be more than 1 because there's 14 men, obviously, right? And the same goes for M3 because M3 is between two women, right? So what we're going to do is we're going to take all this again, paste it, but this time it's going to be, but this time, wait, you know that M2 has to have at least one man. Same with M3 all the way up to M9. So you can say that M2 is greater than or equal to 1, right? And then that means that m2 plus 1. That's basically how it is. I don't know how to explain that. It's just that if m2 is greater than or equal to 1, then you can transform that inequality to this expression. So if you substitute 0 for here, you're going to get 1. So, and this expression has 1. Like, I don't know if that was a good explanation. It's just that this is equal to that, right? And the same thing can go to M3. M3 has to have at least one man. So that's going to be M3 plus 1, right? So that's going to go all the way up to M9. So M9 is the last one where you're going to have M9 plus 1, right? And remember, M10 doesn't have anything. Neither does M1. M10 can be greater than or equal to 0. So M10, I guess you could say it's M10 plus 0, which is just M10 by itself, right? So now, hopefully you got that. Now, you add all of these into the expression. So it's not M2, it's M2 plus 1. It's not M3, it's M3 plus 1. So let's just add all of these inside the thing. Because we have to, right? All of them have a plus 1 except M9. So after you add up all the pluses, it's going to be that, but all the ones added is going to be plus 8. So now you subtract 8 both sides, and you get that is equal to 6. And then Saad says that the number of variables is n, the total is 14. So the total is k, so k is 14. And then the formula goes n plus k minus 1, choose n minus 1, right? I don't know how to do choose on this board thingy, so I guess this will have to do. So you just basically sub it in, so it's going to be 10 plus 6 minus 1, choose 10 minus 1, which gives you 15, choose 9, which is the amount of ways you can seat these men, right? But similar to the house example we did in the last homework, the 14 men and 9 women can be chosen in different ways. So, so that's going to be a permutation. So that's when you have 14 men, so you're going to have 14 factorial. You have 9 women, so you're going to have 9 factorial. Oh, no, what is this here? After you have that, you basically just multiply them. So your final answer is going to be 15, choose 9. So you know how to write it in proper form, I guess. Times 14 factorial times 9 factorial. That's pretty much going to be it. But I don't know if I understood the permutation factor well, but that's basically how you do it.